What's up, everybody? This is your last one for Jumpstart, so I'll try to make it as short and sweet as possible. This is one of my favorite lessons to teach. This is over equations. I'm sure a lot of you have seen these quite a bit. I'm sure your teachers taught them to you in a number of different ways. I'm going to try to just hit the high points and just try to cover the parts that I think you really need to know to be beneficial, and we'll kind of go from there. So this is TEK 8.8c, and it says model and solve one variable equations with variables on both sides of the equal sign that represent mathematical and real-world problems using rational number coefficients as well as constants. So again, we're going to break down all these words. Hopefully you know most of them, but if not, this will hopefully help you understand the rest of the video. So the first one is model. And model is really what we use when we're trying to use images or pictures to show us how to solve a problem. I'm not going to do a whole lot of modeling. I've got tons of resources, so if it's something you want, I can show you what they are. But I think right now at this point, after finishing the 8th grade year, we really want to be able to solve them opposed to describe them or use descriptors. The second part is solve, and all the word solve means is find the answer. So when we're solving a problem, that means that there is one answer that truly makes this fit. I guess there could be multiple answers if we're looking at something like an inequality, and therefore you have a range of numbers. But instead of just having a simplified version or getting something down to its smallest form, we're going to have an actual concrete answer. And with that answer, we could take it, plug it back into the equation, and then produce a proof that shows that it does still work. Next is a variable. Oftentimes in math, we use the letter X for this. But really, you could use any letter. You could draw a camel, I guess, if you wanted. It's going to be some unknown number. So variable is an unknown number. And the reason we call it a variable is because it varies. That answer could be different depending on the rest of the numbers in the problem. Equation. Equation, as simple as this sounds, is any problem with an equal sign. The way that we can remember that is because the word equal starts with E-Q-U-A, and the word equation starts the same exact way. So equal sign and equation go hand in hand. Equal sign is just these two lines right here. And what that means is that both sides, the left and the right side, have to be the exact same. Doesn't mean that they're going to be the same numbers or look the exact same, but the left side and the right side have to be valued at the same. A good example of that would be like 50 pennies on one side and 2 quarters on the other side. Yes, they look different. Yes, we have a lot more on the left side, and yes, the left side might weigh more, but the value of those two pieces are the exact same. The equal sign is probably the most important term in math because it balances everything out. Okay, rational numbers. These are any numbers, positive, negative, that are decimal or fractions. Okay, so we're gonna have decimals or fractions. And the reason that this is so important is because what this is saying is that you should be able to solve any variable problem with any number in it, whether it's a big, large number like a billion, or whether it's a really small number like 0.001. Either way, you should be able to solve them and be able to work with them. Coefficient, this is your copilot. Oftentimes you're going to see problems that look like this, 3x. Your coefficient is this number that comes before the variable. It's attached to the variable. And what that means is it's going to be really important because we have to multiply or divide to get that number away from there. And finally, your constant is going to be any number that does not have a variable attached to it. Any number not with a variable. Okay, so that is the vocab for this. I'm going to go ahead and flip it over. We've got a good bit of problems to work through today, so I want to make sure we pound through those pretty quick. But I hope that this is easy, and I hope it makes sense and a good refresher for you as you go into Algebra 1 next year. Okay, here we go. So I've broken it down into 3 sections. We've got the one-step equations, the two-step equations, and then some multi-step equations. If you look closely, I've got problems that are just constants, no fractions or decimals. Got some more over here with a fraction and with a decimal. I want to just kind of give you some variety of what you're looking at. Okay, so number 1. The whole purpose of this is we are trying to get our variable by itself. We want to isolate it. And so what that means is that anything that is on the same side as the variable, we have to do the inverse operation to get rid of it. So right here we have a -4, which is the same thing as saying -4. And the way that we get rid of a minus is to add. So we're going to add 4 to both sides. The reason I'm adding 4 to both sides is because if I'm adding 4 to the left side, this is going to create the number 0. But I have to be very fair, okay? Math is the most equal and fair subject that you're ever going to talk about. and whatever's done to the left must also be done to the right. 7 plus 4 is 11, therefore x equals 11. It's that simple. That's how you solve the equation. If you wanted to check this, which I won't check all of these just for time purposes, but I could take this 11, and since x equals 11, I could rewrite the number 11 in for x minus 4 equals 7. Well, 11 minus 4 is 7, and 7 equals that. Okay, going on to the next step over here. What I've got negative 0.6x is equal to 42. Okay, so what we're going to do is we're going to divide both sides by negative 0.6. Both sides by negative 0.6. Okay, so we're going to do 42 divided by negative 0.6. So we're going to have 42 divided by 0.6. Got to move our decimal over one place. Move our decimal over one place. So now I've got 6 going into 420. Okay. 6 into 4 is 0. 6 into 42 is 7. 6 times 7 is 42. Subtract those out, we get 0. And so therefore, our answer is 70. Since we divided by a negative, then the answer has to be negative 70. And if we wanted to check that, we could do some math on just a little calculator here, just for time purposes. And what I'm going to do is I'm going to do negative 0.6 times 70. And we get negative 42. I'm sorry, it should be negative 0.6. Negative 0.6 times negative 70 gives us positive 42. There you have it. All right, 2 steps. A little bit easier. I'm sorry, a little bit harder, but nothing different. And so what we're going to do here is we're going to take 2x plus 5 equals 21. Remember I told you the first step is we're trying to get our variables by themselves. We want to eliminate them from any other numbers. So because of this plus 5 right here, I've got to move the plus 5 over. But the inverse operation of plus 5 is going to be minus 5. And if I subtract 5 from this side, I get 0. If I subtract 5 from this side, I get a positive 16. So now I've got 2x equals 16. We're going to divide both sides by 2 because I'm still trying to get x by itself. And the opposite of division is multiplication. And x is going to equal 8. Now to check our work here, we're going to have 2 times 8 plus 5 equals 21. Order of operations says multiply first. That's 16 plus 5 equals 21. 21 equals 21. Good to go there. All right, next, moving on to number 5 here. All right, so again, we're trying to get our variables by itself. I've got my x over here. We'll come back to the 5 here, but let's get rid of this 7 first. This is a plus 7. So the inverse of plus 7 is minus 7, which means it's going to be minus 7 on both sides. Well, this becomes a 0, and this is going to become a negative 10. So now if I go to my next step, we're going to have x over 5 is equal to a negative 10. Okay, now, I'm going to get a little crazy here. Just bear with me. In order to get rid of this, we've got to multiply by the inverse. This is technically, there's an imaginary 1 right here. And so in order to get rid of this, I've got to multiply this side by 5 over 1. Well, 5 times 1 is going to give me 5. 1 times 5 is going to give me 5. And that leaves me with 5 over 5x. 5 divided by 5 gives me 1. So now I'm left with 1x. And 1x and x are the exact same thing, which means that I'm now totally isolated with my x value. But since I multiplied this side by 5 over 1, you guessed it, I got to multiply the right side by 5 over 1 as well. In order to turn negative 10 into a fraction, we're going to put it over 1. Negative 10 times 5 is going to be a negative 50. 1 times 1 is 1. 1x is equal to negative 50 over 1. And so therefore, I'm going to have x is equal to negative 50. Easy does it. All right, moving on to this next part here. We've got 4/10 x plus 9 2/10 equals 10. What I want to do is I'm trying to get my x value by itself. So I'm going to get rid of this 9 2/10 by subtracting here. Subtract this side by 9 2/10 as well. So I'm going to have 0.4x is equal to 10 minus 9.2, which is going to give me 0.8. So now I've got 0.4x is equal to 0.8. Again, we're trying to get our variable by itself, so we're going to divide both sides by 0.4. 0.4. And we're going to come out with x is equal to, just checking my math here so I don't lie to you, that's what I thought. X is equal to 2. All right, so I'm moving down these multi steps. I don't know if I'll get through both of these just because of time purposes, but I'm gonna at least go through number 7 and then we'll see where we're at with number 8. Okay, so the only difference here now is that we have some variables on both sides of the equations. Nothing's changing. All you have to know is that you can only combine like terms together. And what I mean by that is you only put x's with x's and non-x's or constants with non-x's. So what I'm gonna do is I'm going to move all of my variable ones to the left side. So this 3x right here that I want to get rid of, minus 3x, minus 3x. Well, let's see what happens here. 5x minus 3x gives me 2x, minus 2 is equal to negative 3x, subtracted from 3x equals 0, plus 4. If I want to rewrite that, that's 2x minus 2 equals 4. But now I'm back to a 1 or 2 step equation here. I've got to get my x's by themselves. So what I'm going to do is I'm going to add 2. That's the opposite of my negative 2 here to both sides. Well, negative 2 and positive 2 gives me a 0. 4 plus 2 is 6. So now I've got 2x plus 0 equals 6, or 2x equals 6. Now, final step, I got to get rid of the coefficient, this part right here. So I'm going to divide both sides by 2. And I'm going to get x is equal to 3. All right, let's go ahead and try to do this fraction one real quick to see where we're at. Hopefully this will be a little bit helpful for you. Okay, so here we're talking about adding and subtracting some fractions. The biggest thing is we have to have common denominators. And I know we didn't talk about that in the TEKS, but that's something that hopefully at this point you already understand the concept. So what I want to do is I want to go ahead and get all of these fractions to have common denominators. So what I'm going to do is I'm going to just know, or I can multiply. 2 times 5 gives me 10. So what I want to do is I want to make all of these fractions have a denominator of 10. So 2 times 5 gives me 10, which means that 3 times 5 is going to give me 15. 5 times 2 gives me 10. 3 times 2 gives me 6, and my x stays. 2 times 5 gives me 10. 9 times 5 gives me 45. 5 times 2 gives me 10. 4 times 2 gives me 8. And now I have these common denominators so I can work with everything. It's much easier now than trying to guess or estimate where they would actually go. Okay, so now same rules as before. We can only combine the like ones together. Only ones with x's can only go with ones with x's, and ones that don't have variables, ones with don't have variables. So what I'm going to do here is I'm going to subtract 15 over 10 from both sides. These ones are going to cancel out, leave me with a 6x over 10 is equal to 30, because 45 minus 15 is 30, plus 8x over 10. The same thing now. I need to get my x's over here, so I'm going to subtract 8x over 10 minus 8x over 10. That's going to leave me with a negative 2x over 10 is equal to 30 over 10. Okay, we're so close now. Now all we need to do is just get our final variable, our final 10, our final negative 2x, I'm sorry, by itself. So I'm actually going to take out another piece of paper here just so that I don't run out of room. And I'm going to rewrite it now. And we're going to have negative 2x over 10 is equal to 30 over 10. Okay, so what we're going to do is we're going to multiply this side by its inverse, which is going to be 10 over negative 2. The reason we're doing that again is because these will cancel out. Negative 20 over negative 20. 10 times negative 2 is negative 20. Negative 2 times 10 is negative 20, which becomes 1, or just x. So if we multiply this side by 10 over negative 2, then this side must also be multiplied. Well, 30 times 10 is going to give me 300. 10 times negative 2 is going to give me negative 20. So now I've got x is equal to 300 over negative 20. Well, we can just simplify that. We'll knock off our zeros here. And now I've got 30 divided by 2, which is going to equal 15. So x is going to equal a negative 15. All right, y'all. I know that was a lot. We talked a lot about fractions. Probably a little bit overwhelming at first. Hopefully it makes sense. If not, let me know. This is your last video. You've got one more lesson tomorrow, and then a quiz is the day after that, and then your post test, and you guys are done. Proud of y'all. See you later.